Remote sensing, especially sea surface temperature readings from satellites, are an essential part of conservation today. We need to know the temperature of the ocean. However, these satellites and the sea surface temperature data only reads the skin of the ocean, a few millimeters deep. So when we're measuring the temperature, we really don't know what's going on even 10 centimeters beneath the surface. The space agencies and the data providers, they have great mathematical models in order to extrapolate the actual value of the temperature of the ocean from that millimeter, correcting for wind, correcting for day and night and things like that. But when it comes to what's going on beneath the surface, it's really hard, and it's impossible for remote sensing to do that at this stage with the technology we have today. So last year I launched a project called Project Hermus as a reference to the messenger god. The idea is to use a community of divers, the Cousteau divers, worldwide, in order to reveal the temperature of the ocean, to hack the ocean, to complement these sea surface temperatures with in-depth in situ measurements from divers worldwide in near real time, which would allow us to know that temperature, to know that data, to identify the thermoclines. Thermoclines are boundaries in the ocean of different temperatures where the temperature changes very quickly. And you can't see these thermoclines by satellite imagery and remote sensing, unfortunately. Scuba divers worldwide have dive computers, and these dive computers already measure the temperature of the ocean, and they've been measuring it for the past 10 years. All this data exists locked away inside the dive computers of divers worldwide. And what we're trying to do today is to get these divers to contribute this data so that we can reverse engineer those temperatures over the past 10 years and to deploy an array of high precision calibration instruments through dive centers worldwide in order to get a good reference reading as well in the future, going forward. In order to complement this remote sensing of the temperature of the ocean, there are buoys. There are networks of buoys in the high seas that sound down to the depths of the ocean to measure myriads of parameters, not just temperature. And those are great, and they're a perfect complement to this Earth observation, this remote sensing. But they measure the temperature in bulk. Today, in 2016, there's nobody measuring the temperature on the scale of ecosystems on coastal shallow waters. And most of marine life is coastal. So if we are to manage these resources, manage this life, and conserve that wildlife, we need to know that data. We need to know that temperature. We need to be able to model the system beneath the surface as well as the surface of our planet in order to better protect it for future generations.
Satellite data sounds very remote because it's collected by big organizations and it's far away, but not all data is collected like that. There's some citizen science. Tell me about the citizen science you've been involved with.
Citizen science is about basically trying to get the public to take observations for us, so in situ measurements. And a project we've been involved with had sensors strapped onto surfboards. So what this was taking sea surface temperature measurements using the surfer as the kind of vehicle. So rather than have a boat or a buoy, and actually the coastal zone is really hard to deploy sensors in. It's very high energy. And there's a lot of stuff going on. Because it's so abundant in life, you can have the sensors being covered in algae and seaweed and all this stuff. So what happens is if you instrument the surfer or the public, they go out, they take a measurement, they come back. And if you have lots of them doing this, actually you can get quite a large database of measurements. So I think there's something like 500,000 surfers in the UK.
So you want to put them to work?
Basically, the idea is that they're already there, right? They're already out there, every week or every other week, especially in the summer. So they're already doing the journey and getting into the water, and so all we have to do is give them the little sensor, and then we can process that, and you can create not only long maps but long time series, because people tend to go back to the same beaches, so you can start to look at distributions of measurements around the coast of the whole UK, or there's projects also going on in America and other places. But also the hope is that because they're making observations, they become a bit more engaged and they want to know, right? So they're saying, oh, it was warmer today than yesterday, why, right? So getting citizens not only to take measurements for the sake of us, but to take measurements so that they understand that there's change going on. They might, if you had a citizen taking measurements for 20 years, they could say, 10 years ago it was 2 degrees colder every winter. So they really see the impact.
So how does it work? There's a little device. How big is it?
Oh, so it's about the size of a 50p piece.
And so it gets strapped onto the surfboard and then on the underside?
So it attaches to the leash.
Right.
So that way when you're at rest, it's sitting down in the water, it's not right at the surface. And then we also attach, or we give the surfer a GPS locator. So that allows us to tag where the temperature was taken. We wrote some software so that you can get retrieval on the surfing performance. So that way you can kind of make it a game. So
they
while
might stop giving you data if you tell them they're all rubbish at surfing.
well, you might say, okay, you give us the data and we say, well done, you caught 20 waves today, your fastest wave was this fast and all this kind of stuff.
And can they see the data can they download it before they send it on to you, or do they just send back the device?
So at the minute, the project was in a kind of proof of concept stage, so we were showing that the data was, we used it to match up with satellite data and again try and validate coastal sea surface temperature measurements. And so basically you took the sensor back, you plugged it into a laptop, which they could do, but that data wasn't in a particular user-friendly format. The idea is it would become something that you could have on your phone, very easily, a quick interface, and then, yeah, you can have lots of people. They can, they could compete at how many waves they've caught, or they can compare temperature measurements with their friends, or whatever.
And what's the name of this device, or the system, the project?
So the little sensor was called a Tidbit, and it was a project led by Bob Bruin at PML. We're now looking to move that now into a kind of more regional scale. So that was done mostly in the southwest.
And is it still running now, or is it we're waiting for the next iteration?
It's running in as much that the sensors are still functioning and we're still taking data. But in terms of expanding the net, we've got some connections as to people that are interested in expanding the network in Portugal and Spain and some in America. We're just basically looking now to make the act of taking the data easier.
And so how did your satellite data match up? When you took all the citizen science surfer data, you compared it with what these satellites way up in the sky are measuring, how did the satellites do?
So the satellites do pretty well actually out in the open ocean. As you get closer to the shoreline, they perform less well because you have things like river plumes coming out. You can have very quick temperature changes when you have, for example, the sea goes out and then it comes in over sand that's been warmed by the sun. So the surfer data tended to have stronger extremes. So you would get high temperatures and cold temperatures than the satellite was detecting. And also from some of the surfer data, we could even see things like rip currents and really small features, along a beach. But at the broad scale, the satellites were doing pretty well, except for right up against the coast.
Because that's somewhere where satellites struggle, is up against an edge. Yeah. So were you able to use the citizen science data to improve the satellite information near an edge, or is that still one stage further up?
That's the next step. So this was just saying, can we take data that's of use and could be usable? And then once you have a sufficient number of people taking those measurements, you can start to try and improve the SST retrieval algorithms in those areas, especially with the improvements in satellite resolution, as we're starting to see with the modern satellites.
I love the idea of this, because basically you're taking people who think they're having fun, yep, and you make them do work that they don't have to do because they're doing it anyway. And you get data.
Yes.
It's a win all around that, isn't it?
It doesn't have to be surfers. It could be kayakers. It could be, as the sensors get smaller, it could even be recreational swimmers.
I swim.
Yeah.
I'll have a sensor.
Yeah. You just attach it to your swimming gear or whatever, and it tracks the temperature for your swim. So, yeah.
But then that brings problems, doesn't it? Because obviously, if you have people making measurements, there are places where people go, and they might stay in the warmer water. Yep. If I was a swimmer and I was carrying a sensor, it might be up against my skin. So yep, how do you then got to be very careful with the data, haven't you? So, how you use it.
So this comes into kind of the concept of big data, and the way big data it kind of functions and helps scientists is it's not about your measurement. It's not about a single point. What it is over the course of a week, you have 100 people going in, all taking measurements, and so therefore they capture some of the variability, but the averages work out to be usable. So you might have, someone forgets to take a sensor off, puts it in their pocket, gets in their car, it gets really hot, but you analyze all these hundreds of data points, you remove all of the, let's say, corrupt or anomalous data, all the errors, and so this is why when we GPS tagged it, we could see when you'd left the beach. So, if we have a point of temperature measured 10 kilometers from the beach, we know to exclude that. But so it might be that, you stay in the warm water, but then the next day someone goes, it's a little bit cooler. And then over the week, we get a good accurate reading of the average temperature for that week.
So the game is it works as long as lots of people join in.
Yeah, the more people work, the better. That's how kind of big data functions.
The fact that all this remote sensing data is being made available readily to people worldwide on a massive scale. It's all open source and all accessible. It empowers really any citizen to look into that data, to look into the system of our planet and to understand and to even conduct his or her own research and try to find things that are of interest to that person.